So what we're going to do in this episode, we are going to try and do the draw. Now, when I was a kid, maths wasn't my strong point. It soon did, once I really got into it. But I'm going to show you, we're going to do it as I did as a kid. And then if we've got time, we'll see if we can make it more efficient. Because when I've looked at it, and it can be made more efficient. But we'll code it as I did it when I was 16, 17. And we will then see it working. And if we've got time, we may do another command, but then again, I don't know. I might just spend time trying to make it more efficient. But if I don't, then we'll do the draw and the circle command and see if we can get those two going. But unfortunately, I haven't got any slides for the circle command because I haven't done any, so we'll see. So today, we are going to primarily do the draw command. So the draw is we're going to draw a line from one place to another, right? And we're going to work out how to do it. Now, people think drawing a line is dead easy. It's easy peasy lemon squeezy. It ain't. You've got to work out the best way of doing it. Now, the way I did it as a kid has some self-modifying code in it, and very clever self-modifying code in it, but because we're going to try and make this a cartridge, we'll do it self-modified first, and then we'll have to convert it into a non-self-modified code, because if we do it on a cartridge, it'll be on a ROM, and we don't want to do self-modifying code on a ROM because you'll never be able to modify it. So that's where we've got to do some changes, but we'll run through it as it is now, and then when it comes to carting it, we will change it and try and make it run as a cartridge program. So, getting into it. Last week, we discussed that this was our screen layout. So we are talking a Y value from 0 to 199 or 200 in pixels, and across the bottom is 0 to 319, which is 320 pixels. And we have arranged it that the plot, the two routines we wrote last time, which was place and dot, I think, if my memory serves me right. Place works out the memory location we're going to affect, and then dot works out which pixel in that memory location we're going to affect based on the X and Y that we send into it. So let's work out how we're going to do this draw. So the first thing, we need to draw a line. So there you go, there's a line. Nice and easy, isn't it? That easy. But no, not quite. So what we're doing is we're going to draw a line between 2 points. We're going to draw a line from there to there, or we're going to draw a line from there to there. Our draw routine is not going to care which way it goes. Some draw routines do, where you only can draw from low to high. That's a bit of a pain. Does the BBC do it? No, it doesn't. I know it's another one though. It's another computer that only allows you to draw from the low point to the high point in a increasing direction rather than a decreasing direction. So this line I'm trying to pictures paint 1,000 words, Mike. Pictures paint 1,000 words. Right, so this line that we've now got on the screen has a Y1 point and a Y2 point. So the Y1 point is where it starts, the Y2 point is going to be where it finishes. Same with the x1 and x2. So the x1 is the starting point, the x2 is the end point. And so the way we're going to draw this is we're going to pass in to BASIC two sets of xy coordinates, the starting location and the end location. So normally to draw a line is you use a load of Pythagoras and hypotenuse mathematics and stuff like that, which is, yeah, it's all well and good, but you don't really need to do that. You know, this angle here, and I think it's the sine of this angle gives you where it is on here based on that. We're not going to do that, right? What we're going to do is we're going to work out the difference between the start and the end point. So in case of the x, we're going to, between x1 and x2, going to work out what the difference is. Same with the y, between y1 and y2, we're going to work out what the difference is. That gives us our range on both axes, yeah? So in this particular case, the difference in x is greater than the difference in y, right? And remember that rule. So if we have a different line, so this is a different line, so y1 is starting high, y2 is ending at low, x1 is starting low, and x2 is starting a bit higher. So the difference between x and y, so dx is going to be a lot smaller than dy, but dy is going in the wrong direction because y1 is going to say around 150, y2 could be 50. So that's the difference of a minus 100. So you've got to remember these little tweaks and creaks and all that. Because what we're going to do is we work out the differences and we find out which one's the biggest. And the reason why we find which one's the biggest, because the biggest one is the one that we're going to iterate through. So in this particular example, we are going to iterate through the y-axis because that has got the biggest difference. And then we're going to work out where on this y-axis is the x point. So we're going to work out where the point on the x-axis we need to set for the y-axis. Now, for this one, the x-axis is the biggest differential between x and y. So in this particular case, we would iterate along the x-axis and then work out what the corresponding y value is to get this line. So there's a lot of checking to do. So remember, all right, the first thing you do is you have to work out the difference between the two axes and then find out which one's biggest, yeah? Because which phase, yes, the longest. So which one you do, the longest one. And the reason why you want to do the longest one, because if you do a short one, it doesn't give you many iteration pixels to right. If we go back to here, if we run along the x-axis all the time, in this particular instance, you don't have many pixels to work out where the y one is. So effectively, you'll end up with gaps on the y-axis because every time you move a pixel, the y could have dropped 10 pixels. Yeah? And moved across again, dropped another. So you end up with dots. Now, if you run along the long axis, so if we run along the y-axis here, then the differential for x is a lot smaller. So you should never ever get a jump or a gap in your line. Is that so, my friend? Is that so? Well, you'd have to work, you know, measure it in both directions, mate. So if we go into this sort of a... My camera's frozen. Has it? My camera hasn't frozen, has it? No? Not according to me, it ain't. Anyway. So, this, what you see on the screen now is the two different scenarios where... So the two different scenarios where where we either work along the x-axis or we either work along the y-axis, yeah? And and the code that I wrote as a youngster doesn't matter which direction it's gonna go. So it could run in this, like in this scenario, x1 to x2 is in an incremental line. This one, this line here, y1's at the top, so that this is high, y2's at the bottom. So this line is going in a decremental index on the y-axis, because remember, we'll be running through the longest differential. So in this case, we're running through the y-axis. In the first one, we'll be running through the x-axis. I thought people would say that, oh, it's like I'm back at school again. All right. Now, the way we do it is once you've worked out the longest one, that is the one that we're going to increment in pixels. So in this particular x-axis, let's say that's 100 pixels long and the y-axis is only 75. So what we're doing, we're saying, right, for every 1 pixel on the x-axis, that's 75 divided by the number of x pixels. So it's 0.75. Yeah. So the difference between that point and that point is 0.75 of a pixel, which is less than 1 pixel. But we need to add it. So it starts there. Points. Next pixel comes along, it's 0.75 pixels high, which is the same one. But the next time is 0.75 pixels again, which would be 1. Well, we'll be doing a few math problems anyway. So, and that is how we work this out. So we're going to be stepping through the biggest differential. So in this particular instance, the x-axis. So we'll be running pixel at a time, at a time, at a time, and then working out where the y one is. And the way you work it out is you divide the long by, no, you divide the short by the long, gives you your differential for every step, and then you start from there and you add the differential for every step, and it slowly works its way up there. Now, because we're working in binary, no such thing as a fraction. They are whole numbers. So, ladies and gentlemen, we're going to be messing around with the floating point accumulator. Now, if you've never heard of one of those, it's a software-based accumulator that BASIC uses, that it uses to work out all its floating point mathematics. So we are going to be using that. Like I say, that's what I did when I was a kid. When we've got it working using that, then we may think about how we can make it more efficient by not using the basic mathematical routines, and work out the routines ourselves. So how to work out a divide routine to then use for the differential. But remember, we're talking fractions here, so we have to work out a fraction divider, right? Which is not difficult if you know what you're doing. But I want to show you how I did it as a kid. We're going to code it how I did it as a kid. So there's going to be the self-mod code in there and stuff like that. And then, and also how to use the floating point the basic floating point accumulator. And then if we've got time, we may convert it or try and convert it into the more efficient way of doing it. But like I say, we might just go on to the circle and continue with that. And then the next stream, once I've worked it all out, because I've got quite a bit of it worked out, not all of it though, because I got sidetracked with the R point problem. Right, so remember, steps of drawing a line: start point, end point, work out the difference between work out the difference on the x-axis and the y-axis, work out which is the biggest of them two, then divide the small one by the big one. Gives you your differential. And then run through the big axis. So, let's get started. So today is the 14th. And we are going to add I'll put S on there. We are going to add draw. And we'll see how far we get. But we do have a floating point accumulator. You just don't know where it is yet until I show you. Remember, we are gonna get you hot chocolate. All right then, I'm gonna send you to sleep, guys. All right, here we go. How can I switch basic off, FaZe? We're using basic to run the program. Alright. We can't switch basic off. Yeah, in games you would, yeah, but I mean in games, when we come to make it efficient, we use binary fractions like I did in Neptune Lander. You would use binary fractions. You wouldn't use floating point accumulators. They're too slow. They're too slow to work out. So that's what we're going to do, right? So first things first, let's create a new file. What's the command? Oh yeah, inc draw command. Right, where is plot? I like this header. Come here, you. Right then, draw command. So this basic function puts a line on a high-res screen. So the syntax is going to be plot on that is draw, and it's D Shift R, I believe. Yep, D Shifted R. Now we are going to have 4 inputs. We're not going to send you to all to sleep. That's not going to be good for my ego. Right. So we need 4 inputs. In fact, we'll do that. So we've got X1 and Y1. And we're going to have X2 and Y2. So that's what we're going to need. And the syntax for it is, is going to be this. Draw X1, Y1 to X2, Y2. that is our syntax for this command. So let's get started. Commodore. Now this, like I say guys, this is gonna get pretty hairy, alright? So the first thing we need to do for the draw is we need to get our coordinates, our parameters. So the first thing we need to do is JSR get number 2. So this is going to get x1. So we've already written that command, that function. We wrote it last week when we did the plot. So we're in get number 2 is getting a 2-byte number from basic. So A and Y will be set. So store A, which is going to be the low value. So x1 low. And Y is x1 high. So we've now got x1. So the next thing we need to do is, if you look at the command, we need to check for the comma. So we've got a function for that, JSR baz underscore check for comma. So once we've checked for a comma, then the next thing is we need to get Y1. So that's a single byte value because Y only goes from 0 to 199. So we can use the basic command called baz and get byte. So get Y1. The next thing we need to do is we need to then, next thing to do, we need to store it first. So store store X. That's the end result of that. Store X in com1. Y1. Now we need to check for the 2. Passing around the chocolate, are we? Hello, Doctor. So now we need to check for the command 2, and the command for 2 is 164. So we're going to load that, and then we're going to JSR baz underscore sync. There we go. Basically what that does is that looks for that command. Alright, we're not going to evaluate the 2, it's just a word for us to separate x1, y1, x2, y2. And then we're just going to do the whole thing all over again. So we're just going to grab all this lot and paste it there, but this time it's x2 and y. Oh, why are you doing that? Y2. So there you go. We have got our parameters out of the basic line. So if I put on RTS on this, compile it up, we could put draw. It won't do anything because we ain't told it to do anything. So now we need to work out whether we are within the confines of the screen. Because if we're not in the confines of the screen, we've got to produce an error message. So draw evaluate x1. Yeah, you're right, Doctor. It's not really needed, but when it comes to reading it, you know, x1, y1, 2, x2, y2, makes it easy to read. But yeah, you know, the more basic graphic cartridges. Used to do that. I think the BBC did that when it did draw. X1, Y1, X2, Y2. Straight after, off the bat. I like to be different. I like to be different. So we're going to evaluate X. Because wow. Okay. Right. So we need to evaluate the X, because we need to work out which direction we're going and work out the differential. Yeah. So let's do the check. So we're going to load com x1 high. We will compare it with com x2 high. Let's put some comments in here. And then we've got, let's see, they're both the same. One's bigger than the other. One's lower than the other. Right, so the order you would do that is you would test for both to be the same first. So branch if equal, and we'll do that. So this one is saying that x1 high is equal to x2 high. Carry set. So we're testing it for being greater than, so x1 is greater than x2. It's greater than x2 high. So the last one would be branch if carry clear, which is x1 is less than x2. Right, so let's see. So this should, and the reason why we do the branch if equals first is because branch if carry set is greater than or equal to, yeah? So we have to eliminate the equal to first before we can do the greater than. So here we're doing in x1, I think it is, no, x high, I've labelled that wrong. Oh, I got some bits. Dockster, oh, thanks for the 100 bits, mate. Cheers. Right. So we've worked out now which is for the high byte anyway, which is higher, which is lower. Yeah. So now we're working out when both xi and x1 high and x2 high are the same. Yeah. So we then have to test the low byte to find out which way we're going. So let's load com. Have I double M? Double M? It's not double M, is it? Oh, it is. Let's change all these. Can't have all my variables wrong. Naughty, naughty. Yeah, okay. Right, so x1 low, and we'll compare it with com x2 low. So now we're actually comparing compare, what did I put there? Compare high byte, compare low byte of x1 and x2. So in this particular case, we're going to, if x1 is lower than x2, that's the ideal scenario. So branch of carry clear at x1 is less than x2. So x1 is less than x2. Ooh, keyboard's gone, different colour. So we've now tested for less than. You might as well forget about testing for greater than, for equals to, because it's irrelevant, because that's just one line, yeah? So what we need to do now is we need to go x1 is greater than x2, because we've tested for less than, so this is greater than. So just put a comment in there so we know what we're doing. So x1 is greater than x2. Now we have to work out the difference, all right? We have to work out the difference, and this is why we're testing which way we're going, because we don't want a negative number, all right? We want a positive number out of this. So this is saying x1 is greater than x2, so therefore we need to subtract x2 from x1, because x1 is greater than x2. Yeah, with me? Yeah? So we're going to set the carry, and we'll load x1 low, subtract com x2 low, and store it in com difference. So this is the difference of x low byte, right? Then we're going to do the same for the high byte. So we load com x1 high, subtract com x2 high, store it in com x delta high. So the same thing, difference of x high byte. So remember the rule I was saying. First we have to identify where they are, then we have to work out the difference. So this is working out the difference of the x line, right? Now this is where the self-modifying code comes into it, and this is where I was a complete cheat and a how can I put this, a wizard at doing it, right? So we're going to load $38, and this is the set carry instruction, and we're going to load x with E5, and this is the subtract 0 page instruction. So those two bytes, one is the set carry and one is the subtract from a 0 page instruction. And basically what I'm doing is I'm setting up the maths routine to work in the right direction, yeah? So I then created a command called prepare calc, which alters the xdraw routine to subtract. Now we'll get to this function in a bit, but this is where the clever bit comes into it. Now we've done that, we can then go to draw eval y. So we've, in this particular case, we've finished with x, we've worked it out, we've set up the calculation routine, and better put an extra character because I've just seen it. And we've set up the x calculation routine, and now we need to evaluate the y. But we can't do that just yet because we've only done x1 is greater than x2. Now we need to do x1 is less than x2. So effectively we are doing exactly the same thing. So copy that, paste it there, and less than. So this one is in that direction. So we need to subtract 2 from 1. 2 from 1. Now, the difference here is that this is now going to be different because we're not doing 38, which is the set carry. We're doing 18, which is the clear carry. And this one, E5, is not going to be E5, it's 6-5, which is, any guesses? Add 0 paid instruction. Then with those 2 digits, we prepare the x calculation function to do addition. With me? No? Yeah? Sure. It sounds very convincing. We'll get to the prepare calculations in a minute because we need other routines in place to make it work. So now we've done that, we don't need this in because that's where we are now. So draw, in fact we'll just copy that, paste it there. So now we're going to do exactly the same thing for the y-axis. Now the y-axis is a little bit easier because we're not talking 2 bytes anymore, we're talking 1. So LDA com underscore y1 compare com underscore y2. So we're comparing compare y1 and y2, just keep the comments similar. All right, mate, not a problem. Am I dropping? I've not dropped any frames, so I seem to be all right. All right, mate, we'll talk. You can catch me up on the VODs anyway. Right, so we need to. So there's 2 possible outcomes for this: is less than and greater than, or equal to. So we'll do the less one first. So branch if carry clear, which is less than, and we're going to say y1 is less than y2. So y1 is less than y2. So that's going to go if it's less than, which means that we're left with this one. y1 is greater than or equal to y2. So if y1 is greater than y2, then we're going to subtract, yeah? That's why the SEC is in there. So LDA com y1 subtract com y2, store it in com y delta. So this is the difference of y. Then we are going to set up the same thing as we did in X. We're going to set up the calculation function. So LDA. So it's going to be exactly the same thing. $38, which is the set carry instruction. LDX hash $E5, yep, which is the SBC, open bracket, X, comma, Y, 0 page instruction. Chili crashed Hazel's stream. Excellent. Like it. Oh, I like it. Right, so here we are going to JSR prepare ycalc. So this is preparing hey, welcome back, Mike. Right, so alters y draw routine to subtraction, to subtract. Then we go jump. Now here I've got jump draw 4. Really? Draw 4? What's that mean? So we're gonna call it something now. Start draw. So that's what we'll go to. Start draw, jump draw 4. Right, so we now need to do the other thing, the other way. So y1 is less than y2. So y1 is less than y2, which is the exact opposite of this. So we'll just copy that. And we're going to change it. So it's CLC. Oh, no. No, we don't need that, do we? No, yes, we do. Y2. Get rid of that. Subtract y1, store it in the difference, and this time it's 8 and 6. So this is CLC, ADC, and we're altering the Y draw to add. Yeah. Now, what we've done, right, is we've worked out which is the highest number of x1 and y2. Then we've subtracted to get the difference, but we've also set the draw routine to go in the right direction. So if x2 was higher than x1, it's always going to add as it's moving along. But if x2, if it was the other way round, and x2 was lower, so if x2 is up here, lower than x1, then we're going to subtract that way. Yeah, so it sets up the calculation routine to subtract. So it does exactly the same thing for y. So we're setting up the calculation routine depending on which direction we are going. So now we need to do the start. I've got draw eval, so I'll do draw start. We'll do that. So now this is where the fun starts to begin, because now we're having to work out, in fact, not draw start, what should we call this? Draw delta calc. That'll do, because that's what we're going to be doing. We're going to be working out the delta So we've worked out the delta of x and we've worked out the delta of y. Now we need to find out which is bigger than the other. Right? So how do I do it? Oh yeah, that's how I do it. Right. So we're going to, because x and y are 2 bytes and 1 byte respectively, we have got to cheat on the x high. So we're going to load x high delta. Alright, and then we're going to compare it with 1. And the reason why we're doing that, because the y will never get to 1. So if com delta is 1, we definitely know that the delta of x is bigger than y, because we've already got the high byte is 1. So it will be bigger. There is no arguing about it. So that's what we're having to do. So if it's equal, so we're going to branch if equal to, now I've got com4_1. Not going to do that. So we're going to go and say x delta is greater than y delta. So x delta high is greater than 1. There we go, that's better. So yeah. So is x delta equal to 1 because y will never be? Sad face. Right? In fact, as y will never be. There you go. That looks better. So we know that x is bigger than y. So we don't need to do anything else. But if x high is 0, then we need to check x low against y. Yeah? So we're going to load com x low and then compare it against com, and got to make sure, put the d's in, yd. Now if it's greater than or equal to, then we're going to oh, Twitch is flaky tonight. Okay. So it looks like I'm back. Stop gobbling up all my bandwidth. What do you mean your Minecraft bandwidth? It's me Twitch streaming today. I've just been told to shut down the Minecraft server. Right. Right. So we're back, yeah? Right, so where was we? Oh yeah, we are comparing the y delta now. We're comparing the y delta, so we're trying to figure out which is big between x and y. So branch if it's greater than and equal to, then we need to say xd is, the x delta is greater than the y delta. Yes, but it's the same. Yeah, we've just had a bit of a network glitch here, I think. All right, we'll let everybody get back in, so get rid of the advert and all that. even though I tell it not to do it. Hey Jason, morning. Right, so hopefully you're back after my little crash. So we're going to say XD is greater than YD. There, because it's the same thing. So we're going to the same place. So, draw 13? Draw 13? Why are we going to draw 13, John? What's draw 13? Oh, right. Okay. Okay. Right. Draw 13. I know what draw 13 is now. So, we're now saying that we now know that we've branched away because x is greater than the x delta is greater than y delta. So this is now because y delta is greater than the x delta. No, no, it didn't freeze. Honest, no, just thinking. Right, so we need to then, so here, so we're gonna jump to draw. So the y delta is greater than the x delta. So we're gonna draw along y axis. Yeah. So that's what we're going to do with that. So we've worked out that we've compared the x delta and the y delta together, and now we're going to have to draw along the y axis. So this means that we are drawing along x axis. So so that is actually this. So let's give it the proper name, like so. I've written a chess program in BASIC, but the problem is the computer kept cheating. So I don't know yet. I've given up on chess because I'd got the chess program within the 2K in BASIC, but it was cheating, and if I added more rules to make it work, it would have gone over the 2K mark. So I don't know yet. I'm trying to think of another game type to try and do. It's a shame because I really wanted to do a 2K chess game. Be on a par with that ZX81 1K chess game that came out many millenniums ago. Right, so where are we? So that's that. X delta is not equal. So this is X delta is not equal to 1. And then this one is basically saying X delta is greater than or equal to Y delta. And this one is saying that Y delta, X delta is less than Y delta. Yeah, Because effectively, if you decide to write a basic program, you've only got 2K of memory to play with. Only 2K. So I worked out that I could store a 64 by 60, an 8 by 8 array. So it's 64 elements in BASIC, and it wouldn't blow the 2K barrier. But that reduced my memory down to 1 3/4 near enough, because of the overheads of BASIC on the array. And I've managed to get the chess program running, where you could put in the coordinates, but the computer kept cheating, and basically there weren't enough rules to govern the pieces. And the more tests I put in, I just blew through the 2K boundary. So yeah. Yeah, if it was a 4K, then I probably could get away. I probably could get away writing the chess game in 4K. I think 2K was just a bit too tight, so I've got to think of a different game. Yeah, I know people have got games published, but that means they must have had games ready to go already, or in a state that just needed tweaking to finish it off. Because I haven't got any games. I mean, I had Pet Frogger. That would have fit. Pet Frogger would have fit in that criteria straight away. But it's published. It's on GitHub. It's not a new game. Anyway, so we're now drawing along the x-axis, which is draw 4.1. So first, and Laxity stole the code. All right then. So we're going to draw along the x-axis. So now what we need to do is we need to test for the obvious. So we're going to load the y delta, and then we're going to test for 0. Right? Because if it's 0, it's just a straight horizontal line. We don't have to do any mathematics. So we're going to say branch if equal to 0, and we are going to say oh yeah, so draw work out x ratio. Yeah, there's some idiots out there. I agree that it's just not right. Right, JSR, draw x line, y is 0. So that does that. And then we're going to jump to draw. I'm going to call it draw 8, because that's what I've called it in the code, so I don't forget. So draw 5. Let's have a look. Draw 5 is there. Wow. I was a clever bunny back then. So let's do the... It's that one. Is that one? Getting distracted with what's happening next door. So 4.1, 4.2. I didn't want to call them the same. So this is 4.1. I used to be clever, yeah. I used to be clever. Not clever anymore. So draw along x-axis. That's this. Jump to draw 8. So 4, 2 is draw along the y-axis. Draw along the y-axis. X delta is greater than y, so we're drawing across the x-axis and jump. Oh, jump. That's draw 13. Oh, that's miles away. So what we were doing here? Oh yeah, it's working out the ratio. It's doing this. Right. So, I've left that there so I know where I'm going. Right, so this is where we're working out the ratio between x and y now. And this is where we're going to be messing around with floating point accumulators. So load x with com y delta, LDY with com x high, x delta low, and LDA com x delta high. So we're loading the three. So we're loading the three registers. Oh no. Oh, hang on. Oh, okay. I'm overwriting. So we're storing x in low. So we're loading the y delta into the increment of x low. Yeah, that's right. That's right. Then we're loading 0 because y doesn't have a high byte. Storing it into com x high. Alright. Then store y, which is the x delta low. In the y incrementer, and then load x delta high. Ooh, this is going somewhere funny. I'm sure we'll find out where it's going in a minute. And that's going into, I ain't even got a variable for this. Store it in 246. What are you doing, John? Right, so now we are going to JSR, and this is to divide. So we're going to do divide x by yy. So that's the routine we're going to do, which is draw 7 on here. So let's go to draw 7. There we go. So I am going to move down a bit, and we're going to put this routine in. I'm going to put this routine here, down here. So this is where we're going to divide what's in XX by YY. Right? That's why we did the flip, because we're we're working out the X ratio to Y, because X was lower than Y. X was smaller than Y. So this is going to be the fun bit. So we have to we've got to pre-populate the floating point accumulators before we can do the divide. So the way to do that is we have to load A and Y with the integer values we want to convert to floating point. So LDY com, and it's XX low and XX high. So we load A with the high byte, load Y with the low byte, and then you do JSR bass underscore this. And what this does, this converts XX into a floating point value in FA1. Floating point accumulator 1. Now, we'll call it FP1. That's better. Floating point accumulator 1. FPA1. There we go. So, BASIC has 2 floating point accumulators, 1 and 2. So we're putting XX into floating point accumulator 1. Then the next thing we need to do, excuse me, is we need to move floating point accumulator 1 into 2. And I'll explain this in a minute. So we need to do another basic function, which is move floating point 1 to floating point 2. So we've moved, we convert into floating point accumulator 1, and you can't convert into floating point accumulator 2, unfortunately. It doesn't exist. So you have to convert it into 1 and then move it into 2. And the reason we're having to do that is because we are now going to load 2546, which is the differential high. Yeah. And then, which is going to be 0, and then load Y, which is com YY. And then we're doing the same thing again. So JSR baz underscore. And so this is now converts YY into floating point value into a floating point value in FPA1. So we've got XX now in floating point accumulator 2, which is this bit. So we take XX, the 2 bytes of XX, we convert it into a floating point, which converts it into floating point accumulator 1, and then we move it to accumulator 2. And then this bit takes YY, converts it into a floating point, and puts it into floating point accumulator 1. Then we need to do some floating point sign manipulation. So we're loading 66, and this is the floating point. We're going to OR with 6E. You talking to me? We're going to load in 66, EOR, 6E, store it in 6F, and then we have to load 61. And that is working at doing the signs, right? And then we do the divide. So we are going to do a basic divide. There we go, FP divide, which effectively does floating point accumulator 1 equals floating point accumulator 2 divided by floating point accumulator 1, which is equal to XX divided by YY. Understandy? No? And what that does, we're going to leave, so basically we're working out the ratio between x, the differential of x and differential of y, yeah? And then it puts that end result in the floating point accumulator 1, and we're going to leave it there. We're going to leave it there. So that's working out the differential. Then, back up here, we are going to and then we're going to do, what we're going to do is, because we've now got the ratio, which is probably a fraction, you know, 1.659, yeah, we're going to have to put it somewhere safe, because we're going to have to use it, yeah. So we are going to call a routine, draw, move FPA1 to memory. So we're going to create a function that does that. Put it here. And what we're going to do is you tell BASIC the memory location where you want to store this floating point. So the place we're going to put it is, we're going to tell it LDY hash $02, and this is the address high byte, LDA hash $F0, address low byte, jump, and once again another basic function. I think it's move floating point to memory, float FP1 to M. So we're taking the contents of floating point accumulator 1 and we're going to store it at O2F0 in memory, right? So we're basically taking that and storing it there, right? And then we're going to jump to draw 8. Now I think draw 8 is the drawing routine because we've got it here as well, all right? Now, back to where we were before. Excuse me. So draw 8 is there. So what's draw 8 doing? So we're storing it in 0. All right, okay. So this is drawing along the x-axis. So we need to do the same. Branch, COMYD, branch if not equal to, draw 5, that's that, which is there. Okay. So draw 5 is draw set FP floating point accumulator 1 to to 0. So we are loading LDA #0, and we are loading Y, I think. Yeah. Transfer A into Y, and then jump to baz underscore. So that's setting floating point accumulator 1. Oh, it's not JSR, it's JSR, not jump. So we're now setting floating point accumulator 1 to 0 because we are working on the fact that the Y was 0. So we're setting that, putting into floating point accumulator 1, and then we're storing it in. So storing it in the memory straight away. So this is because when we run through the line, we'll be adding this ratio. So it's going to be 0. All right. So that should be that. So draw if equal. That's draw if not equal. Branch if not equal. And then B42 JSR 5, which is that. So then we are, where are we? We are doing that. That is there. Set floating point accumulator to 0, and then going to draw 8, which I think is the main drawing routine. So let's check. So we've done that. We've checked. So what we've done, we've prepared the deltas. So we've worked out the deltas. We've prepared the deltas. Now we're calculating the deltas. Which one's bigger than the other one? So we've done where we draw along the x-axis, and then we've worked out the ratio. So we're still on the x-axis here. So we're still, yeah. And then draw 13 is the Y version of it. So we're carrying on. So draw 8, that's where we're here. So this is the start, right? This is the start. Draw 8 is draw x-axis start. So that's draw 8. So we're gonna do that. So draw x-axis start, which we can do down here. So this is now, we are going to literally run through the x-axis start point and end point 1 pixel at a time, and then work out the Y value to draw the line, right? So we need to initialize our code. So LDA $0, store it in com XL low X line low byte. Initialize the high byte. Now, we also need to reset the floating point conversion, byte conversion. So store in 65, store in 64. So they're the bytes that you would do a floating point conversion back to. Right. So draw x-axis loop. So this is the start of the loop. So we're going to basically work out where we need to go and on what point. So we're going to run through the x-axis from start to finish, and then what we're going to do is we're going to initialize the floating point accumulator to the start point of where the y-axis, the y start point is, and then we're either going to be decreasing it depending if y2 is bigger than y1, or increasing it depending if y1 is bigger than y2, or the other way around, sorry. So we need to then load in the start points and the y differentials. So this is where it gets a little bit confusing, and you need to stay alert. So if you've got your Red Bulls, now's the time to start drinking them, because this is only the x-axis. We need to do the y-axis after this. So we are loading y and x with the x point that we're looking at. We're going to load a with the y differential, or y delta. We're going to compare it with 0, because if it's 0, we don't need to use any floating point. Branch if equal to draw. Oh, get off. Draw x as yd is 0. So that means we're gonna break away, and I'm gonna put a JSR draw 12, because that's where we're going after that. So, but we're not getting there just yet. So yep. So this is now the internal. So that's not the looper. I thought that was the looper. Hang on, where are we jumping back to? Draw. Oh yeah, we're jumping back to draw 9. So it is definitely the looper. So this. Come here, you. So draw 12 must be re-establishing the floating point number. Right. So we're going to load A with com y1. So we start loading with our starting y point. That's draw 10. Just put that in there for the moment. We're going to add the contents of 65, which is set to 0 at the moment. Store it com y. So that's basically done our adjustment. Then we're going to load com x load. X1 low. Now, had to draw 11. I don't know what we're doing. Are we looping back? No. Oh, yes. I know what draw 10 and draw 11 is. Let's just check. Yes. Right, okay. So these are draw 10. Okay. Right, I need to give these some proper names. What should we call this? Work, draw, work out y from x. And this one is draw work out x from x. I think we're on the right. I think we're on the right axis. I'm not sure. Right, so these two labels are important. We'll see in a bit why they're important. So draw 11. So that's draw 11. So we're doing CLC, ADC, com, x low. Store it in com, x low, LDA, oh, capitals, com, XL high, ADC, com, XL high, X1, yeah, I thought it was. Store it in com x high. So this is now working our next position. On the x-axis. So once we've done that, so we've worked out, so where are we? Here. So we've worked out our y coordinate here, and we've just worked out our x coordinate here of the position we're running through. Then we do JSR place, and we know what that does, works out where the memory address is, and then JSR dot sets the dot. Alright, and because, so we've worked, this is working out now the so we've done the we initialized it to y1 or whatever, and then we've set that point on the y-axis for that x-axis. So now we're going to increment the x-axis, XL low, branch if not equal to at bypass inc. So this is inc com XL high at bypass inc. So we've just incremented to the next point on the x-axis. So next thing we need to do is we need to check that we haven't blown our x2 point. Yeah. So this is where we do the check. So load com XL high, compare it with com XD high, branch if not equal to draw 9. Now draw 9 is the looper. Draw 9 is the looper. So if the increment hasn't got to XL, we're fine. Then we need the low. Then we need to compare the low byte, because if XL high and XD high are the same, we need to compare the low byte. So LDA com XL low, compare with com XD low. Branch if carry clear to the looper, and then this is then that means it's done the line. Right. So we've done the line. That is basically drawing the line when we're using the x-axis because it was the biggest one. So where we are working out the calculations. So this draw, right? This is what we're going to do now. So this is draw. Work out new y point. Right. So we're passing in. So if I grab that and put that there now. So we're passing in y, x and y, which is XL low and high. Yeah. So the first thing we do is we need to transfer x into a, because we need to convert it into a floating point, and a is low and y is high. So we've already set y, but we had to set x because we're using a here. We're using the accumulator here, so we couldn't do it. So we're going to transfer that. Then we're going to JSR. And we're going to convert it into a floating point. There. So this is convert to float in floating point accumulator 1, where x was equal to low and a was equal to high. So y is equal to low and the accumulator is equal to high. Right, so we've converted our current, where are we? Where's the point? This one. So we're converting our current x location to a floating point. Then we're going to move it to floating point accumulator 2. So we're moving 1 to 2, move FP1 to FP2. And now we need to grab the the fraction that we worked out, the ratio. We need to grab the ratio we worked out when we did xx divided by yy, yeah? So we need to go and grab that. So we're going to load the accumulator with our memory address, high, load y, keep forgetting it's L, high and low. Load the accumulator with our memory address low, yeah? So this is effectively getting the yy divided by xx ratio from memory. Then we're going to run the basic command, move memory to floating point to number 1. So that's taken the floating point number from memory and putting it into floating point accumulator 1. And this is where the fun happens, because we have to do all this EORing again, because we've got to set the signs. It's a bit silly, but we have to set the signs. So we load LDA EOR with 6E, store it in 6F, and LDA 6.1. Right. I think that's just setting both accumulators' signs. And now what we are going to do is, now we've prepared floating point accumulator 1, and floating point accumulator 2, we are going to do the magic trick of multiplying them together. So what this is going to do is floating point accumulator 1 is equal to floating point accumulator 1 times by floating point accumulator 2, which equals our new Y position. You with me? You with me, guys? Then we need to then convert the floating point, the resulting floating point number, back into a binary integer, so a word integer value. So that's using the basic command that. So this basically converts floating point accumulator 1 into integer, which is equal to accumulator equals high, y equals low. Or $64, $65. They're the two memory locations. So the accumulator equals high, y equals low, but it also sets 64 and 65, and that's why we initialized them here. All right. So we run through, we check that the difference of y is not 0. If it is 0, then we initialize floating point accumulator 1 with 0, so it never does anything. And then we plot throughout the x-axis. Now, like I say, this was when I was done when I was 16, 17, round about that, and using proper maths to work out the line slope, which is multiplying the x position with your ratio. Yeah. This, when I looked at it, I thought, oh, this is really, really slow because you're having to work out each point, and you don't really need to work out each point. This is where the next stream is going to be, because the fact that we need to, we can do this a lot quicker. Right, so we've got a couple of routines that we haven't coded yet, which is prepare xcalc and prepare ycalc. So we need to work them out, but in fact we haven't done the other one, but we can still put them in. So we're gonna put them in. Right, so we'll do the xcalc first. So this is where it's working out the calculation, which is this bit here, this bit, yeah? So what we do is we are going to, I'm going to rem this out, store in draw 16, but store in draw 11. Now draw 11, that's 10, that's 11. Yeah, draw 11. Yes. Then we are going to transfer x into a and store, rem this out, store in draw 16 plus 1. Don't worry about this, I'm just putting it in to remind me that we need to change it, yeah? Store it in draw.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, I've got another follower. Thank you, whoever that was. Right, then we're going to EOR with 8 and then store it in 11, which is that plus 1, and store it in that plus 10. Right, so we need to work them out because I want to work them out. Oh, thanks, mate. Thanks for following demo. So it's going. So it's putting 9, 1 and 9, 1 and 10, 1 and 10, 1 and 10. Draw 11, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it's there. It's got to be that one there. Plus 1. Yeah. Plus 1. That's 0 plus 1, so that's that one. So 0, 1, 2, 3, 4, 5, 6. Oh, hang on, these are 2, aren't they? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There. So we need to no, I think they're fine. We're not going to insert anything in there. And the other one was this one, which is that place and that place there. Right. So return, do an RTS there. Then the other one was calculate Y, I think it was. Prepare Y calc. So we'll do the same thing again. So this is straws 10. 10, 10, 10, 10. 10 is that. So store in 10, store in draw 17. Because we've only done one axis at the moment. Y, store in that plus 1. And then we're doing, now we're doing EOR -8 and store it in draw 17 plus 1. So that's going to get remmed out and then RTS. Right, so this basically what these two routines do is this is the X, yeah, for axis X. There's also going to be a routine for axis Y that we've got to do as well because we've just done the X version. And what happens is it changes this CLC, this add, and this add to be either CLC or set carry, or add or subtract, depending on which way. This is why I was on about the self-modifying code. Yeah. And this is where we're going to have to do some changes to make it represent a cartridge, because we can't do this in a cartridge. It's a no-no. Unless we copy all that into a lower memory space and then use it. But I want to rewrite it to make it a bit faster, and we can certainly make it faster for doing that. So that is, would you believe it, only the X-axis. Because I think the other one, where is it? Did we leave a pointer to it? Where is it? I'm sure we had a pointer to it. That's x-axis start. It was this one, isn't it? There we go. Draw along the y-axis. There we go. So basically, we've got to do the whole thing again. Where we're doing the y-axis. And it's basically almost exactly the same thing as before. The only difference is we are drawing against the y-axis and working out the x-axis position. So let's get that started. You alright? Buddy boy, what are you doing? Eh? Nico! What are you doing pestering mummy? Eh? Pestering mummy? Eh? Good boy. Right then. So we're going to do exactly the same thing. Alright, so we need to check that we're drawing a straight line, and then we need to work out the ratio, but this time instead of xx divided by yy, it's going to be yy divided by xx. Alright, so we're going to load com. So this is going to be slightly more complicated than the other way, because we got 2 bytes we have to test. So compare with 0. Branch if not equal to 13.1. So what did we call it when we did the other one?
Then he'll eat that grass again. The observer will detect that the grass has been eaten and will fire the
Draw along x. So we did work out ratio, didn't it? That's the work out the ratio. Yes, it is. So that's going to branch if not equal, work out the y ratio. Then if they are the same as 0, then we need to compare com xd low, compare that with 0. That will be truly the x differential is 0. Branch if not equal to the same place. And then we do JSR5. What's JSR5? So we've already written that code. Right. So that code is this. Where are we? There. That. So that's setting the floating point accumulator to 0, because we've now identified that it's a flat line. So it's going to be, well, flat line, it's going to be vertical flat line. Yeah. So JSR5, then we load, store it in com xd high, and then jump to draw 14, which is going to be the y-axis jump. So now we're going to work out the y ratio. So this is exactly the same as what we did for the x. Let's have a look. Let's have a look.
Yeah, well, that'll just tick along. And then when you've got enough, you need to carve it.
Not quite the same.
Right, oh my god. Don't eat that.
So, LDY. So we're setting up our parameters. LDX because we need to use all of them. So XD low, STY into COMY, initialize to 0, 246, store X in COM XX low, LDA COM XD high, so initializing the X coordinate. Then we're doing JSR 7. What's JSR 7? Right, that's working out. That's that. Yep, that's that. So it's doing the divide. So it's then doing the divide. Go back, just to make sure. And then it's doing JSR 6, which I think is the move. It is. Move, where's the move? Where's the move? There we go. Move floating point to memory. So we've done basically exactly the same thing as what we did the X, but we're just repeating the whole process for the Y. It's a pain up the backside, but it has to be done. Has to be done. Right, so here we go. So we are now in the loop. So draw 14, so that's going to be that. So this is effectively draw 14, which is that. So we need to initialize our Y coordinate. I hope this works when I've finished. I do hope this works. Store it in 64. Store it in 65 because we need to initialize those. This is now the looper. And it's not X, it's Y. Right. LDY, COM, YD, YL. LDX 0 because we don't have a high byte for Y. LDA COM XD high. Compare it with 256, 255 because we changed it, so we know that it's a flat line. If it's a flat line branch, if equal to, what did I call this one? If it was a flat line, there we go. Draw Y when XD is 0. And then we are JSR draw 12. Now draw 12 we've already done, which is this, work out new point. Now that says work out new Y point, so I'm going to change it, work out new point, so it works on both X and Y. So work out new Y point. Yep, that does it. Work out new y point, and then we are now in the crux of it. So we're now going to so we're working our way through y, so we're going to have to work out the x points. All right. So LDA com x1 low, so that's our starting point. Draw 16. Right, this is our draw 16 and 17. So so that's going to be this. Work out y for y. So this is 16, so we will change this to do that. Someone's noisy. Yep, so that's 16. So CLC, add 65, store it in com. So we're working with x's now. X low, LDA, com, XL high, add 64. Store it in com XL high. Oh, no. It's X. Then we load com Y1. Now this is draw 17. So what was the other label I called it? So we can match it. There we go. Work out. Think that's that. Because we're working out the x for y, yeah. So this is working. So this one is working out y for y. So that's the other one. So that goes there, and that one goes there. So CLC com Y1 YL, store it in Y, JSR place, JSR dot inc com YL, LDA com YL, compare it with com YD delta, branch of carry clear to draw 15, which is that. And then RTS. That's too easy. Too easy. But that is the Y. I hope this works. Right. That should be it. So we've worked out. So here we're getting the details. Yeah. Then we're evaluating in the X, which is bigger of the two. So is X1 bigger than X2, or is X2 bigger than X1? And then we alter the calculation to accommodate. Then we evaluate the Y, which one's biggest, Y1 or Y2, and of course then we accommodate the calculation routine in preparation. Then we work out which is the biggest in the deltas. Is y bigger than x? And depending on which one's the biggest, we run through the axis with the biggest number. So if it's x or y. Right, so let's try this out, shall we? Oh, this is gonna be fun. Alright, let's put it in. So inc ASM inc draw command. Oh, if this works, I will be amazed. Right. So word com draw -1. That's the tokenizer. We've got draw in there. Right then. Here goes nothing. Right then. Was it Alt R, wasn't it? Right. Graphic. Turn the graphic on. So 20. Draw. Here we go. 10, 10 to 100, 100. Let's see what happens. Fingers crossed. Oh dear. Well, we got a line. Got a line. Let's do 10, 100. That is what we've just done. Oh, it's going the wrong way. Right, so 20, 10, 10 to 100, 30. Let's try and see if we can get an angle on this. Right, so we've definitely got one of our tests the wrong way round. So this is on the X draw working out Y. It's saying that the Y is 0. So our draw, let's have a look. So our x-axis, here we go. So y delta is 0, branch if not equal, work out ratio. So it's saying our y delta is 0. Just put a breakpoint there, not there. Yeah. It's yeah, we'll get there. So our y. Right. F8 is debug, isn't it? So, okay, 10 graphic, 20 draw, 10 to 100, 100. Let's do the simple one. So it's not even hitting our breakpoint. Not even hitting our breakpoint. Right, so where are our... Let's get our labels. Where's our memory locations? Here we go. O2A8. Hey? Right, O2A8 is going to be here. So we're looking for the Y delta, which is there. But all right, doesn't say what the number is. Here we go. Here we go. So YXD is O2BC. O2BC is there. See, Y delta is 0. Let's step through this. Commodore. Commodore. — 8845. Right, here we go. 8845. So we will pause it there. There we go. Right, so we'll run it again. So here, screen. Put that back in there. Run. Right, let's see what we've got. O2B2. So this is 10, 100, 10, 100. Right, okay, so it's read the numbers right. So let's just move it on a little bit. So it's gone there. So, okay, it's subtracting B3. That's 3 from B1, which is right. And storing it in B7. So that's the X differential. Now it's doing the Y differential. Should be exactly the same. It stores it in B8. Oh, it's coming out 0. Oh, yeah, that's the high byte. What am I thinking? That's the high byte. So it's going to affect the change on there. Now we're loading the Y, which is OA, Y1, and then 10, Y2. Then we're subtracting 6 from 5. Get 5A, stores it in BC. There we go. So that is. Then sets the routine up for that. Loads B8, which is 0. Compares it with 1, which it isn't. Loads B7, which is 5A. Compares it with 5A. So it's equal to. Loads BC. Where's BC? Is 0. Is it 0? No, it's 5A. Compares it with 0. Okay. Load BC. Store it in B9. Yep. BA. F6. That's right. We'll skip them two because they're just floating point basic compute. breakpoints. Oh, reset. Oh, what do you reset for?
Right, so if you clicked on Y, and then you just select them, you can see them all listed.
F11. Right, okay. So my floating point mathematics is out. O2 F0, where are we? That's here. There is no floating point number there at all. So it thinks it's drawing on the oh, where's my breakpoint gone? Right, it thinks it's drawing on a flat line, which we've got in here. Which is this. Where's the other one? Here. So YD is equal to near 0. YD. Ooh, hang on a second. Let's put a breakpoint there as well. Oh, it's not. Is it? It's not going into the breakpoint, is it? Is the breakpoint being passed along? No. Why is the breakpoints not being passed along? Okay, let's see if we can find them. Well, there's one there. That's one. BC. O2 BC. 5 A's. So they're right. So it must. So it's my floating point that's failing. Alright. Let's just check some. Let's do a proper straight line. So we're gonna run. Right, so that should be a straight Y line. And it's not. It's doing it on the X. So we've got our tests are wrong. Right. So 20, let's try the other way then. Draw 10, 10 to 10, 100. That's going backwards. Right, so we've got our tests. Our tests are wrong that are doing the delta testing because it's going backwards. Why? That should have gone Y that way.
We need about, I think it's about 6 stacks of scaffolding, but we are.
Hmm.
I'll come in. I might see if John wants to come in, and we'll have to get some stone saws and warm a bit of the
Right, so it's these tests I need to check, double check. Because what it's doing, it's just drawing a straight line across the bottom. So it's running through the x-axis, and it's doing the increase, but for some reason it's not it's not drawing the y's properly. So I'm just got to check that I've got my variables set right. Can you hear that? Can you guys hear that?
My Christmas tree looks amazing. Yeah. Oh, stop moaning, you bar humbug.
Right. Start the x low. Start the x at 0. If the y delta is 0, draw a straight line. Sometimes I wish I'd copied and pasted, but I don't want to. Alright guys, I'm going to look at this off stream because I don't want to be boring you guys trying to figure out what's... I've probably got the wrong variable name in there somewhere.
Alright, I'll speak to you later in the week. I'll come in and have a look, see how you're getting on.
I mean, straight away. That's that. Right. That's the greater than. So this is the drawing. Okay, XL low, XL high. Yeah, I don't want to bore you guys while I debug the. I think I've got some variable names wrong. I think more than likely. I want to check that I've got all my variable names right. Because more than likely I've got one of them wrong, and that's why it's always going that way. It's strange that everything is going across the x-axis all the time. So I need to check my variable names just to make sure that I've got them all right, correct. Alright. But on the next stream we'll have it working, and then we'll talk about how we can make it more efficient, because you saw how slow it was. Yeah. And we'll try and make it a lot quicker by not using the basics floating point accumulator. We're going to work out all the dividing and do all the multiplying. Alright. So I will see you in the next stream. Thank you very much for joining me, and I will see you possibly Wednesday. Alright, take care guys. I'll see you in a bit. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.